Self-assessment for day 3 is asking you to write a function that will allow the user to enter in these values. As you can imagine, this would be a much more powerful way to solve these kind of problems, especially if you have 100 of these equations to solve. This was the code that I used for the example. Let's take this and turn this into a function so we can call it any number of times we want to and allow the user to enter in these values. Let's create ourselves a new file. And this will be the self-assessment for day 3. So the question is trying to enter in constants or enter in the values for p, v, and t to compute n. So let's turn this into a function. We'll compute n. And in this function now, I need the user to enter in these values. You've seen the use of the input statement, and I'm going to repeat that here with some very small changes, and you'll see how it is pretty much the same program, except now instead of having hardwired constants, the user has entered them in. With the input statement, you have the option to put in a prompt that you should ask the user for. So pressure in atmospheres would be 1. The next one would be to get V, the volume, in liters. And it's important to be able to ask the user to enter in information with the appropriate unit so that you can answer accordingly. The temperature, let's do temperature in a slight different way. Temperature in Celsius, because normally people don't have temperatures in Kelvin, and that's something I can easily compute on my own. And R, as you can see, is a constant, and I don't need to enter that in from a user. When you're writing functions in Python, it's very important to make sure that the indentation is all at the same level to explain that these 4 statements are part of the compute n function, where these ones are not. Let's get rid of these. We don't need them anymore. The computation for n looks like this. Again, it's PV divided by R times T. And when it's done, I want to print out n. When I look at this function now, I see that I have all the indentations lined up properly. These PV and T's will be retrieved from the user by the keyboard. And I'm going to do my computation, then print it out. I think we want to have one more change, which is not just to print out a number, but to print out some extra text so that the user understands what the value is. I'll do it first to show you the error, and then we'll see how it looks. I want to say something like this. N is going to be the computed number of molecules, and so I say at the end of it, it has that many moles. So it's a shorthand. Let's save this. And again, I'll make this under days 3, always using the .py extension. When I run this, you'll see that I have the %run appear, but nothing else. Remember that defining a function is not the same thing as executing the function. Now that I have the function defined, I can call it here, compute n. The pressure in ATM is the prompt that comes up, and you see that I plan for the extra space at the end of every one of these colons to be able to leave room for the user to enter in some space. If I remember the specific example from yesterday, which I don't, let me go and get those values. And if you look at the website, you'll see that the values are as follows. This one right here. I want to enter in 1.4 ATM. That's 1.4. For liters, I have to remember to put in 0.5 because that's after all 500 milliliters. And the temperature is going to be 20. Now, this is still in Celsius, and so my computation is still incorrect, but I'll fix that in a moment. When I press return, I get this error. This is what's in Python is known as a type error. I've asked it to use the add operator to add a floating point number and a string. This is not something we can do. In the lectures, you can see samples where I take 2 strings and I concatenate them together. And so what I'm going to do is convert that n into a string. Once I've done so, I can concatenate that string with the quote moles, and I will get the output that I want. But I do have to make one more change. As I mentioned, this temperature is in Kelvin, and I want to, sorry, the temperature is in Celsius, and I want to convert it into Kelvin. To do that, you take the temperature, whatever it is, and you subtract absolute zero, which, if you remember, minus 273.15. This statement, when you say, I've got a variable t, and I want to set it equal to this expression, it can be confusing for people who are used to mathematics. Because if this were a mathematical statement, it's completely invalid. No number is equal to itself minus another number. But this equals statement, as I mentioned in lecture, is an assignment operator. This says, set the value of t to be whatever the current value of t is, minus some other number. So now let's save this and run it. So now I'm going to enter in, whoops, made myself a typo there. I'm going to enter in 1.4 atmospheres. My volume is 0.5. My temperature is 20 degrees Celsius, and I get 0.029 moles as I expect. So I've completed the self-assessment here, and what I was able to do was take these values, not hard-coded, but to be given to me by the user. Now, you always want to make sure you add the appropriate comments. And so here I've got my comment up here. This other statement here, I should comment that is this function computes the number of molecules given other values. As we move on in this course, I will come up with more interesting and novel ways to be able to comment your code. This completes the assessment.